Very good morning to everyone. In this lecture, EC 8791 Embedded and Real-Time System, Department of Electronics and Communication Engineering. In previous session, we have to discuss the introduction of the embedded system and also the what are the different type of processor we are using the real-time embedded system in nowadays in electronics industrial oriented, and also what is the process of real-time operating. It is a multitask and multi-scheduling and multi-process and how to scheduled, that is a how to the priority scheduled allocated in your embedded system design, and also the how to the memory can be shared through the communication in between the processor and also the co-processor units. Now today we are going to discuss the evaluating operating system performance. So, what is the title? Evaluating operating system performance. How to perform the operating system. So, here the analysis of scheduling policies is made by the following the four assumptions. So, we can focus the scheduling policies. That is the first one is it assumed that the context switching required zero time, although it is often reasonable to neglect the constant switch time when it is much smaller than the process execution time. The constant switching can add significantly delay in some cases. We have a large ignored interrupt. So the latency from when an interrupt is requested to when the device service is complete, it is critical parameter of real-time performance. We have assumed that we know the execution time of the process. We probably determine the worst case or best case time for the process in isolation. So the context switching time, it depends on the following factors. Number one, the amount of CPU context that must be saved. What are the functions are needed? What are the instruction we are using? These data executed through the CPU, and also the scheduler execution time. So how do the execution can be implemented, what type of scheduling we are prepared. So these are the category of worst case execution or best case execution point. So and also the interrupt latency. The interrupt latency, it is the duration of time from the assertion of device interrupt to the complete of the device request operations. So the interrupt latency is critical because the data may last when an interrupt is not served in a timely fashion. So here the operating system, different operating system, that is a kernel operating system, it can be it's shared to the different devices like a task and also the scheduled. So a task is interrupted by a device. The interrupt goes to the kernel, which may need to finish protected operations. Once the kernel can process the interrupt, it calls the interrupt service routine, which perform the required operation on the device. Once the ISR is done, the task can resume the execution point. So the several factors in both hardware and also the software affect the interrupt latency. How to affect? That is the process interrupt latency become the execution point in the data to send or receive the CPU and also the device. The execution time of the interrupt can handler must be error, and the delay due to the real-time operating system scheduling. The scheduling process may be delayed. So the real-time operating system delay the execution of the interrupt handler in two-way methods, that is critical section and interrupt latency, and also interrupt priority and interrupt latency. So these two methods are followed by the real-time operating system delay execution of an interrupt handler method. So the critical section and interrupt latency, the critical section in the kernel will prevent the real-time operating system for taking the interrupt, and some operating system has very long critical section that disable the interrupt handling for very long periods. That is the device interrupt during a critical section. The critical section must finish before the kernel can handle the interrupt. So the longer critical section, the greater than the potential delay. So the critical section are one of the important source of the scheduling jitter, because a device may interrupt at a different point in the execution of process and hit the critical section at a different point. So the interrupt priority and interrupt latency, it is a high priority interrupt may delay a lower priority interrupt. A hardware interrupt handle the run as a part of kernel, not as a use thread. So we can see the interrupt priorities and interrupt latency methodology. It is a higher priority interrupt may delay a lower priority interrupt. The hardware interrupt handle the run as a part of kernel, not as a user thread. So the priorities of the interrupt are determined by hardware. Any interrupt handler primitives are all user thread, because the interrupt as a part of CPU fundamental operations. We can reduce the effect of hardware preemption by dividing the interrupt handling into two different pieces of code. That is, the first one is interrupt service handler, and the second one interrupt service routine. The interrupt service handler, it performs the minimal operation required to respond to the device, input output device. And interrupt service routine, it performs updating user buffer or other more complex operations. So the conclusion of the real-time operating system perform the evaluation tools. These real-time operating systems, it provide simulators or other tools that allow to view the operation of the process, and switching times and interrupt response time, and also other overheads. So we can analyze the performance of the real-time operating system. We are the Windows CE provide the several performance analysis tools. And instrumentation routines in a kernel that measure both interrupt service routine and interrupt service thread latency. So the operating system bench measure the timing of the operating system takes such a critical section access for the signal as soon. So the kernel track provide a graphical user interface for real-time operating system events. So these are the evaluating operating process, that is evaluating of system performance in the real-time operating system. Thank you for watching this video.